Greetings to every one of you. In this video, we are going to discuss another very important concept from data structures and algorithms, that is analysis of algorithm. Analysis of algorithm deals in finding the best algorithm which runs fast and takes less amount of memory. Time and space are the two major concerns for an efficient algorithm. The complexity of algorithm is a function which gives the running time or the memory space in terms of the size of the input. If the size of the input increases, and naturally the time will be increased. If the size of the input is increased and the amount of space used by this algorithm may also be increased. Here let us see some example. We will discuss about this time complexity and space complexity. Find sum of the first n natural numbers. So this is the given problem. So in order to solve this problem, we have many solutions, and among them I am going to give you the two different solutions. So the first one, we are reading the value number of the natural numbers, and there is a formula available in order to calculate the sum. It is n into n plus 1 divided by 2. Print sum. So this is one algorithm. There is another method of writing this algorithm. Read n, sum is equal to 0, for I is equal to 1, I is less than or equal to n, I plus plus. This is a for loop. So inside the for loop we are performing this addition. Sum is equal to sum plus I, print I. So this is also another way of solving this problem. So here directly we have implemented this formula, and just we have used a loop here. So the complexity of algorithms concern, suppose if m is an algorithm and n is the size of the input, the complexity of an algorithm m is the function, that is f of n, which gives the running time and or the storage space requirement of the algorithm in terms of the size of n, which is the size of the input, the data. So depends upon the input data, the time increases. Depends upon the input data, the space may increases. The time complexity, it is measured by counting the number of the key operations involved in this algorithm. Now let us see how to calculate the time complexity in this algorithm, both the algorithms. So in this algorithm, consider this particular statement. This will be executed for only one time, and similarly this statement is also executed for one time, and this statement executed for one time. So totally all these three statements will be executed for each one time. So totally we have three statements. So the function of this time complexity, it is nothing but it is order of 3. It is order of 3. So naturally whenever it is a constant, we can write it is as a order of 1. Similarly, take this particular algorithm in which this will be that is executed for one time, and similarly this statement will be executed for one time. But as far the for loop is concerned, initially you are taking the value that is I, and this particular statement is executed. The condition is checked if I is less than or equal to n. Let us consider if n is 5. So if the condition is true, the statement will be executed. Then again it goes to the loop. When I is equal to 2, again it will be that is executed one time. Similarly, when the condition that is I is equal to 5, this statement will be executed one time. So totally that is 5 times it is executed, but the loop gets terminated only when the I value becomes 6. So the loop will be that is executed for n plus 1 number of times, but the statement will be that is executed for n number of times. That we have to remember. So this will be executed for n time and this is executed for 1 time. So totally there are it is n plus 1, the loop is executed for n plus 1 time, then plus 1, 2, 3 times that is executed, and this will be executed for the statement that is sum is equal to sum plus I will be executed for n time. So if you add these values, we will get that is 2n plus 4. This is the time complexity. So this can be written as it is f of n is equal to that is order of 2n plus 4. You have to cancel all the constants and you have to consider only the maximum degree in the polynomial. So that is nothing but so you will get n. So f of n is equal to, it is nothing but order of n. That is the time complexity. So similarly, the space complexity of an algorithm, it is measured by counting the maximum, the memory, that is the variables needed by the algorithm. So how many variables that is required in this algorithm, that we have to count. So here there is n is a variable and s is a variable. N and s, these are the two variables. This space of n can be written as order of 2. We have only two variables, that is the n and the s. Okay. So again this can be that is simplified as there is the order of 1. So similarly, as for this particular algorithm is concerned, so here we have a number of variables like n is a variable and sum is another variable. So similarly I is another variable. Okay, that is the n, sum and I. These are the three variables. So this can be written as that is order of that is 3. This is a space complexity, that is s of n is equal to order of 3, and again it is simplified as order of 1. So this is how we can calculate this time and space complexity. There are three cases of investigating complexity of algorithm. One is the best case, worst case, average case. So consider the problem of linear search. So we have a list which contain so many numbers, values, data values, in which we want to find out whether a given value is available in the list or not. So let us consider the item, the given item is available in the first location itself. So no need to perform any search further. So that is the best case. Let us consider if the data, required data item, it is available at last. So the nth element, if it is the nth element, it is called as worst case. The case is called worst case. In between anywhere, if the data item available, then that is what is called the average case. The linear search algorithm is given here. So initially we have the values, that is k as 1 and similarly location as 0. So we are repeating the steps, that is 3 and 4, while this value of k is less than or equal to n, and here we are taking the value. If the item, the given value is present in this the list data of k, then if it is available, then print the location and just come out, exit. So otherwise we have to move to the next location. So we are incrementing the value of this index index variable, that is k is equal to k plus 1. Then again we are checking with the next data. Okay, so until we are getting the result, we are keep on doing this process. But if the data is not at all available, so nowhere the required data is available, so that being the case, what will happen? The value of this location is what actually we initialize as 0, and simply that value will be, there is 0 only. So that being the case, we have to print the message, the item is not found in the list. Okay, exit. So this is an example of this linear search. So with the help of linear search, I explained like best case, worst case and average case scenarios. So in this video, we have discussed time complexity, what is space complexity, and we discuss how to calculate time complexity and space complexity with the help of a simple example, and also the complexity of the algorithm, types of the cases, best case, worst case, average case, with the help of this linear search. Keep watching. Thank you.